Starting from this video, we will cover a few topics related to front-end web development. As the first topic in this video, we will look into DOM along with CSS/OM. Front-end developers should know about DOM, but there are not many people who understand DOM correctly. That's because the explanations of DOM that you can find in books or on the internet are ambiguous and arcane. Let's take a look at this MDN page. It defines the DOM in such a way as the representation of the document, programming interface, etc.
I read it, but I have no idea what it's saying.
Yes, with such explanation, it is difficult for beginners to understand what DOM is and where it is used. To help you understand DOM easily, we will start with a simple and straightforward metaphor and gradually delve into the details. Think of creating a web page as creating a dancing robot. When we code a web page, we write an HTML document. This HTML document is like the blueprint of a robot. It shows what a robot should have, like a head, arms, legs, etc. But it's just a blueprint, not the actual entity. A website runs when a browser, such as Chrome, Safari, or Edge, reads the HTML document. The browser is like a factory. It receives this blueprint written in HTML and creates a robot. The robot made in this way is exactly what we call DOM. According to the HTML, IC, the blueprint, each part was made into a tangible entity. This is the representation of a document mentioned on the MDN page. And this robot can be controlled by the user using a language called JavaScript. In the old API video, I said an API is something that is set up to perform a specific task when given a specific command. So it is called a programming interface because we can give it commands to do the job. Now we can give commands in JavaScript to make this robot dance. The web page is completed. Now, let's consider a more realistic analogy. If a web page was simply about rendering an HTML document on a screen, we wouldn't need something like DOM. You could just parse this document directly into graphics to display on the screen. But the web page needs to be commandable, meaning that the contents can change or functionalities can be assigned to various elements through JavaScript. Therefore, this puppet-like DOM is essential. This puppet can be grabbed and manipulated by JavaScript. By manipulating this puppet with JavaScript, it creates dynamic changes on the web page. Now, let's delve into the code. If you want to follow along with the practice, you can click the link in the pinned comment to view the Notion page with the example codes. Here, you can check out the HTML and CSS codes used in this video, the trees of DOM and CSS/OM, and the JavaScript commands. Click on this link at the top, and you will be able to see a web page created with the examples HTML and CSS codes. First, let's take a look at the HTML code at the top. I told you before that it's like a blueprint for a robot. HTML is a document that tells you what needs to be on the web page and where each should be located. Within the HTML element, there are head and body elements. Inside the body is the header and main. Inside the main are sections, and within them are H2, P, and so on, depicted in such a format. But this document is just a document. These codes are nothing more than text. In order for these texts to have any substantive information and functionality, and for them to execute given commands, they must be turned into something substantive, aka objects. The browser reads the text of this HTML document and creates a substantive entity called DOM. This process is called parsing. The DOM is structured like this tree. At the top, there's the document object, and you can see branches coming out from the HTML node below. The structure of this tree follows the inclusion relationships of each element in the HTML document. In this tree, we only show HTML elements, but in reality, even text and attributes are included in the nodes of the DOM tree. All tags written in an HTML document, their attributes, and the text inside them all take up a place as nodes in this DOM. So what is this tree used for? Let's dig in. This screen is a web page running the HTML document we just saw, along with a CSS file in Chrome. In Chrome or Edge, press Ctrl plus Shift plus J on Windows, or Command plus Option plus J on Mac to open the console window of the developer tools like this. For this video, I've enlarged the console window and placed it on the left. Now, you can type JavaScript code into this console window to give commands to a web page. I've told you that I've posted JavaScript commands on the Notion page linked in the pinned comment. Those of you who want to try out the practice can copy these commands and paste them into this console. Let's first print out this thing called document, which is at the top of the DOM tree. The full command is like this, but in the browser environment, you can omit console.log like this. Then a result like this is output, and if you click on these arrows to unfold the folded content, you can see that the entire structure of the website appears like this. Actually, this is the browser showing in a format such as HTML for the convenience of developers. Now press this button to clear the console, and then, this time, by using this code to look at the prototype of the object, you can see that the document is a JavaScript object of a very large and complex class called HTML document. As you can see, an enormous number of fields and methods are included as components of this single node. You can use these codes to conduct the same test on the body and its inner elements. Every element in this tree also happens to be an object harboring complex data. For those of you who are not front-end developers, there's no need to understand all the example codes in this video. It is enough to just remember that all the elements of this DOM tree are composed of this many pieces of information and functions. In other words, a factory called browser creates this entity known as DOM. It takes every single element prescribed in the HTML document blueprint, manufactures objects from classes appropriate for each type, and connects them in a tree structure. As DOM is created from HTML, CSS ARM is made from CSS. The CSS ARM is also created in a tree-like structure like this. Thus, you can see that the CSS properties written in separate CSS files, internal styles, and inline styles are made into trees like this. Using these commands that can also be checked on the Notion page, you can take a look at the objects of the CSS ARM written in CSS files and internal styles like this. Indeed, you can confirm that JavaScript objects have a great number of fields and methods. The screen we see in the browser is the result of numerous pieces of information in the DOM and CSARM being interpreted. Browsers combine DOM and CSARM to create what's called a render tree. Each node in the DOM creates a render object in the render tree based on calculations from the CSS ARM, including visual elements such as colors, sizes, and positions of each element. Not all elements of the DOM are included in this render tree. Only those that need to be displayed are included, so elements like this section element that has a display property of none are excluded. Think of it as pruning unnecessary branches from a tree called DOM and wrapping a vine called CSSOM to create a render tree. The browser then calculates the position and size of each element to be placed on the screen according to this render tree. As soon as these are determined, the browser paints each element in its respective position, and it combines these multiple layers to create the screen we see.
So DOM and CSS-ARM are components of JavaScript?
They are information and functionality written with JavaScript, not belonging to JavaScript. DOM and CSS-ARM are parts of the Web API. Web APIs consist of functionalities standardized to be provided by browsers. In other words, think of it as functionalities that a proper browser should rightfully provide for users to use via JavaScript. If you visit the Web API page on MDN, you can check what else there is besides DOM and CSS-ARM. The events, timers, web storage, canvases, AJAX functions, etc. that we use when developing the web are all provided through this Web API. In fact, what comes next is the really important part. Remember when we talked about an API being a way to get a job done in a predefined manner? We can use the DOM and CSS-ARM to make changes to our web pages. If you've ever explored web development, these are functions you've likely used. You can paste the codes from the Notion page into the console window of the opened web page to check the changes. JavaScript can be used in various situations, from selecting specific HTML elements or their contents, to changing the text contents of an element, modifying its style, or creating new elements and adding them inside specific ones on the web page. All dynamic changes made using JavaScript after a web page has been loaded occur through this DOM. All of these methods and fields you've been commonly using are all features of the DOM. Just like this, CSARM also provides a function to change CSS rules using JavaScript. But not many of you might have seen such a code. Ordinarily, styles of elements are modified by accessing the style values using DOM, or by adding and modifying classes. This method is more convenient and also advantageous for both performance and maintenance. Also, did I mention that Each of these nodes in the DOM contains all the information about each element. Therefore, the DOM is also used to read information from the web page. Web scraping tools analyze this DOM to find and retrieve the information they want. So to summarize, the DOM is like putting handles onto all elements of a web page. It's for developers to give various changes and events to these elements using JavaScript to breathe functions into the web page. In other words, a web page can do more than just project the design on the screen based on a blueprint called HTML. DOM is a bridge that allows it to be manipulated in various ways using JavaScript. In this video, we've looked at the DOM as well as the CS SOM like this. See you in the next video.